When conductors are derated due to factors such as temperature or proximity to other conductors, the allowable conduit fill capacity may be reduced. The conduit fill capacity is calculated based on the circular mills of the conductors and the cross-sectional area of the conduit. The National Electrical Code, or NEC, provides tables that list the allowable fill percentages based on the number and size of conductors in the conduit. Derating factors account for the increase in conductor temperature due to factors such as, firstly, ambient temperature, secondly, number of current carrying conductors in the conduit, thirdly, proximity to other conductors carrying current, and fourthly, the type of insulation. Let's consider an example. There are 8 legs of 600 mcm THHN wire in two 4-inch conduits. According to NEC Table 310.16, the allowable conduit fill capacity for two 600 mcm THHN wires in a 4-inch conduit is 40%. If you derate the conductors by 20% due to high ambient temperature, the allowable conduit fill capacity is reduced to 40% multiplied by 0.8, which equals 32%. Based on the derated conduit fill capacity of 32%, you would need a conduit with a cross-sectional area that can accommodate 8 legs of 600 mcm THHN wire with a 32% fill ratio. The cross-sectional area of a 4-inch conduit is 12.56 square inches, which meets the requirement. Based on NEC Table 310.16, the allowable conduit fill capacity for 4 600 mcm THHN wires in a 3-inch conduit is 27%. This does not meet the derated conduit fill capacity of 32%. Therefore, in this case, you cannot use a 3-inch conduit for 8 legs of 600 mcm THHN wire even with derating. You would need to use two 4-inch conduits to meet the allowable conduit fill capacity after derating. To elaborate, the National Electrical Code, or NEC, specifies requirements for wiring and protection of electrical systems. Conduit fill is a critical aspect of electrical installations to ensure safe and efficient operation. Overfilled conduits can lead to overheating, insulation damage, and potential electrical hazards. The NEC provides guidelines and tables to determine the maximum number of conductors allowed in a conduit based on their size and type. These tables take into account factors like conductor insulation, conduit material, and conductor bundling. When conductors are derated, it means their ampacity, or current carrying capacity, is reduced due to specific conditions. These conditions can include high ambient temperatures, multiple conductors in close proximity, or specific installation methods. Derating factors are applied to compensate for these conditions and ensure that conductors do not exceed their maximum operating temperature. The NEC provides tables and formulas to calculate derating factors based on the specific conditions present. Conduit fill calculations involve determining the cross-sectional area of the conductors and comparing it to the available area inside the conduit. The NEC specifies the maximum allowable percentage of conduit fill, which varies based on the number of conductors and conduit type. For example, for 3 or more conductors, the maximum fill is typically 40%. To perform a conduit fill calculation, you need to know the size and type of conductors being used, as well as the inside diameter of the conduit. The cross-sectional area of each conductor can be found in NEC tables or calculated using the formula for the area of a circle. The total cross-sectional area of all conductors is then compared to the conduit's inside area to determine the fill percentage. If the fill percentage exceeds the NEC allowable limit, you must either increase the conduit size or reduce the number of conductors. When derating conductors, the allowable conduit fill may also be affected. The NEC requires that the ampacity of conductors be reduced when they are installed in conduits with multiple conductors, especially in high ambient temperature environments. This reduction in ampacity can impact the allowable conduit fill, as the derated conductors may require a larger conduit to dissipate heat effectively. To determine the impact of derating on conduit fill, you must first calculate the derated ampacity of the conductors. This is done by multiplying the conductor's original ampacity by the appropriate derating factors from the NEC. Once the derated ampacity is known, You can use the NEC tables to determine the minimum conduit size required for the derated conductors. In some cases, the derated ampacity may require a larger conduit than the original calculation based on conductor size alone. It is crucial to consult the NEC and follow its guidelines for conduit fill and derating to ensure a safe and compliant electrical installation. Ignoring these requirements can lead to overheating, insulation failure, and potential fire hazards. In summary, conduit fill calculations and derating factors are essential considerations in electrical installations. The NEC provides the necessary guidelines and tables to ensure that conductors are properly sized and installed to prevent overheating and maintain safe operating conditions. By understanding and applying these principles, electrical professionals can create reliable and safe electrical systems. Let's delve deeper into the NEC tables mentioned earlier. Table 310.16 provides the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current carrying conductors in a raceway or cable or earth based on ambient temperature of 30 degrees Celsius. This table is fundamental for determining the initial ampacity of conductors before applying any derating factors. Other NEC tables, such as those found in Article 310, provide adjustment factors for ambient temperature and the number of current carrying conductors in a raceway or cable. These adjustment factors are used to reduce the ampacity of conductors when the ambient temperature exceeds 30 degrees Celsius or when there are more than 3 current carrying conductors in a raceway or cable. The adjustment factors are typically expressed as percentages and are applied to the ampacity values found in Table 310.16. For example, if the ambient temperature is 40 degrees Celsius and there are 6 current carrying conductors in a raceway, the ampacity of the conductors must be reduced by the appropriate adjustment factors from the NEC tables. The derated ampacity is then used to determine the minimum conduit size required for the conductors. It is important to note that the NEC also provides specific requirements for conduit fill based on the type of conduit being used. For example, the allowable fill for rigid metal conduit, or RMC, may be different than the allowable fill for electrical metallic tubing, or EMT. The NEC also addresses the use of different types of conductor insulation such as THHN, THWN, and XHHW. Each type of insulation has a different temperature rating and may affect the allowable ampacity and conduit fill requirements. When performing conduit fill calculations, it is essential to consider the specific requirements for the type of conduit and conductor insulation being used. In addition to the NEC tables and guidelines, there are also software tools and calculators available to assist with conduit fill calculations and derating factors. These tools can simplify the process and help ensure accuracy. However, it is still important to understand the underlying principles and consult the NEC for the specific requirements of each installation. Now let's look at some practical examples of how derating factors can impact conduit fill calculations. Firstly, consider a scenario where you have 4 500 mcm THHN conductors in a conduit carrying a continuous load. The ambient temperature is 45 degrees Celsius. According to NEC Table 310.16, the allowable ampacity of a 500 mcm THHN conductor is 380 amps at 30 degrees Celsius. However, since the ambient temperature is 45 degrees Celsius, you need to apply a temperature correction factor. According to NEC Table 310.15b2, the correction factor for THHN conductors at 45 degrees Celsius is 0.88. Therefore, the derated ampacity of the 500 mcm THHN conductors is 380 amps multiplied by 0.88, which equals 334.4 amps. Since you have 4 current carrying conductors in the conduit, you also need to apply an adjustment factor for the number of conductors. According to NEC Table 310.15b3, the adjustment factor for 4 to 6 current carrying conductors is 0.80. Therefore, the final derated ampacity of the 500 mcm THHN conductors is 334.4 amps multiplied by 0.80, which equals 267.52 amps. With the derated ampacity known, you can now determine the minimum conduit size required for the conductors. You need to ensure that the conduit fill does not exceed the NEC allowable limits. In this example, the derating factors significantly reduce the ampacity of the conductors, which may require a larger conduit than initially anticipated based on the conductor size alone. Secondly, let's consider a scenario where you have multiple circuits in the same conduit. Each circuit consists of 3 current carrying conductors. The ambient temperature is 30 degrees Celsius. In this case, you need to apply an adjustment factor for the number of current carrying conductors, as there are more than 3 conductors in a conduit. According to NEC Table 310.15b3, the adjustment factor for 7 to 9 current carrying conductors is 0.70. Therefore, the ampacity of each conductor must be reduced by 30%. This reduction in ampacity can impact the allowable conduit fill, as the derated conductors may require a larger conduit to dissipate heat effectively. It is important to carefully consider the number of circuits and conductors in a conduit when performing conduit fill calculations and applying derating factors. The NEC provides specific guidelines for these situations to ensure safe and compliant electrical installations. In conclusion, understanding and applying derating factors is crucial for accurate conduit fill calculations and safe electrical installations. The NEC provides the necessary tables and guidelines to determine the appropriate derating factors based on ambient temperature, the number of current carrying conductors, and other specific conditions. By following these guidelines, electrical professionals can ensure that conductors are properly sized and installed to prevent overheating and maintain safe operating conditions. Remember to always consult the latest edition of the NEC and follow its guidelines for conduit fill and derating. It is also recommended to seek the advice of a qualified electrical engineer or inspector if you have any questions or concerns about a specific installation. Electrical safety is paramount, and it is essential to take all necessary precautions to protect people and property from electrical hazards. So always ensure all of the rules and regulations are being followed.